Hello, this is the solution for the practice test I distributed in class today. Question number 1, the amount of material left after 2 half-lives is 1/2 of the original amount. That would be false, and you would have to change the word 1/2 here to 1/4. After 2 half-life, you would only have 1/4. Number 2, fusion means to divide. That would be false. Fission means to divide. See page 562 of your textbook for further explanation about fission. And consult page 565 of your book for further explanation about fusion. Number 3 is true. Radioactive isotopes that are put into the body to modern processes are called tracers. Moving on to the completion. Number 4, an alpha particle is the same as a helium nucleus. Number 5, in the symbol 4/2He, the subscript 4 is the mass number for helium. That's the protons and the neutrons. And the subscript 2 is the atomic number for helium. All right, number 6 is a small problem solving. It says here we start off with an original amount. Original amount is equal to 100 grams. 24 days goes by, so T is our 24 days. And after 24 days, what's left over is simply 6.25 grams. The way I've taught you to do this to calculate for half-life is you set up this problem. N is equal to NO raised to the 1/2 lowercase n, where n is the number of half-lives. And first solve this one for the number of half-lives. And how do you do that? You would do 6.25 grams for n and divide it by the original amount, which would give you 100 grams. This is equal to 1/2 n. Now you need to figure out the number of half-lives. This number works out exactly to be 1/16, which is the same as saying 1/2 times 1/2 times 1/2 times 1/2, or n is equal to 4. The second equation that I gave you is n is equal to T over the number of half-lives is the time that expired by the actual half-life, which is what we're trying to solve here. Rearranging this expression algebraically, we get an expression that says T 1/2 is equal to the time expired by n, which in this case works out to be 24 divided by 4, which is equal to 8. And I believe in this case it's 8 days. That's how problem number 6 is done. All right, I'm going to clear this out. I'll hang on to it until the next one. Number 7, a neutron is a proton. A nucleon is a proton or a neutron. Nucleon refers to elements in the nucleus of an atom. Nucleides that have the same atomic number but different mass numbers are classified as isotopes. The nuclide of iodine 125 contains 53 protons. All you have to do is look at the atomic number. Number 10 requires you to do a little math. The nuclide of gold 197 contains, well, you have to subtract 197 from 79 to get the number of neutrons. If you do that correctly in your calculator, non-graphing type of course, it would be 118. All right, moving on to the short answer questions. Number 11 on the short answer question. What particle will balance the nuclear equation? If you take a look at this, the top numbers have to equal. So the top number here is going to be a 0. And the bottom number, well, what number to 92 gives us 91? It would be -1. A particle with a mass number of 0 and an atomic number of -1 is an electron. So that would be the answer for number 11. Number 12, list 2 practical uses of nuclear radiation. We can say nuclear energy, and we could say some sort of nuclear health. All right, don't stress too much about that one. Number 13, 3 types of radioactive particles. You could say alpha, beta, gamma particles. You could say protons or neutrons, okay? But basically I'm looking for alpha particles, beta particles, and gamma rays. Number 14, what is the range of atomic numbers whose elements are all radioactive? Remember to mind your own bismuth. If you look on the periodic table, bismuth is number atomic number 83. After atomic number 83, all those elements are radioactive. Moving right along, we got complete the following nuclear equation. This one, we have a coefficient here. So you have to keep that in mind, but the top numbers have to equal the bottom numbers. And if you do this carefully, the number 15 works out to be 139 over 50 for tin, Sn. This next one, same thing. This coefficient multiplies this by 2, this mass number by 2, because we have this coefficient of 2 here. So the next one works out to be 63 over 30, zinc. All right, number 7, I kind of explained this one earlier. N is the amount of substance left over after a certain amount of time. N sub 0 or N naught refers to the original amount of the substance, 1/2, because everything goes down in half increments. And N is the number of half-lives. All right, number 18 on the problem solving. We have this problem. All right, so once again, these three problems are all this one's asking straightforward. How much of a sample remains after 3.2 seconds? I like to label everything. So we're looking for N. N is our X. We're given our N0, which is 1.7 grams. We're given T. T, I believe, is given to us as 3.2 seconds. And the half-life for this element is equal to 1.6 seconds. All right? So first thing you might want to do to simplify your life and use this expression up here is calculate N. Remember and recall, this is an important thing, N is equal to T over T1 half. And in this case, it's 3.2 divided by 1.6. Works out to be 2 half-lives. So now plugging everything into our equation, we're looking for N is equal to 1.7 times 1/2 raised to the second power, or basically 1/4 of 1/7. We do that calculation, 1 divided by 4, and multiply that by 1.7. We get the following number of 0.425 grams. That's how we do that problem. Number 19 and number 20 are very similar in nature. They're actually asking you to solve for the half-life of the element. So in number 19, they give us the sample. We have 30 grams. The original sample is 960 grams. We have a time that has expired of 15 minutes, and T1 half is our X. So we plug everything into our first equation of N is equal to N naught 1/2 raised to the N. Solving this one for N, we would get N divided by N0 is equal to 1/2 raised to the N. Now we can plug in our numbers, 30 divided by 960, and we would figure out what that works out to be. So 30 divided by 960 gives us this fraction, 0.03125. What we would do, this is obviously not 1/4, 1/8, nor 1/16, so we would go up to the next increment. We would try 1/32. And 1/32 does work out to be this, so this is equal to, hopefully you saw how I did that, this is equal to 1/32, which means that it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2. We have 1/2 5 times, so we have N is equal to 5 half-lives, which is equal to 15 divided by X. If you solve this equation here for X, X is equal to 3. In this case, we measure things in minutes, 3 minutes. All right. The next problem, number 20, is very similar. In number 20, we're also solving for half-life. So we have N is equal to 31.25. Then we have N original is 250 grams. Then we have a T of 2.00 weeks. And we're looking for T1 half is our X. So now we know that we do 31.25 divided by 250 is equal to 1/2 raised to the nth power. All right, so if we do 31.25 and we divide it by 250, we get 0.125. I believe that could be 1/8, and it is 1/8. So we know that this is equal to 1/8, and we know that 1/8 is equal to 1/2 times 1/2 times 1/2. We're making n equal to 3. Now solving for x, 2 weeks divided by x. So x works out to be 2/3 of a week. 2/3 of a week. Do that in a calculator. 2 divided by 3 gives us this number. Multiply it by 7. It works out to be 4.66 days. 2/3 week or 4.66 days. And they didn't specify in the problem how they wanted the question answered. All right, number 21, I wouldn't stress too much about it. Just understand that fission, things are coming together. Fusion, things are coming together. Fission, things are being separated. All right, moving on to number 22, another series of problems here.